Hey grade 8, welcome back to another one of our video lessons. As you can see, I am in my classroom and not at home anymore, back to school. Hopefully you guys are going to be back to school soon as well. But for this week, let's still carry on with video lectures. So in our last lesson, we went over a bunch of triangles. We learned how to classify the triangles using angles and sides. Remember, we classify angles by looking at the sides. So how many of the sides are the same. So if no sides are equal, it's a scaling triangle, which means that the angles are all different. Okay. Then we have an isosceles triangle where two of the sides are the same, which means that two of the angles are the same, and namely opposite angles of the sides. Okay. And for the third one, if we have an equilateral triangle, meaning all three sides are the same, then all the angles are the same, and those angles are 60 degrees each. Okay. Then remember we talked about having an acute angle triangle, an obtuse angle triangle, a right angle triangle, and how we dealt with that. All right, and then I asked you to do exercise 1.11.1, which was just to classify those triangles. I don't think you guys would have had any issues with this, but if you did, then you can let me know in our Skype session. But anyway, for today, we're going to continue on page 114, 115. I'll do those worked examples for you, and you guys are going to do exercise 11.2 for homework. All right. So let's start on page 114. So I'm going to read the first top part, and then I'm going to explain what that means. So triangles have two important properties, which are true for all triangles. The sum of the interior angles is equal to 180 degrees. This is called the angle sum. Okay, angle sum meaning we sum the angles of a triangle, and the answer is always 180 degrees. Now, if we're going to use, now remember in geometry, as I said, whatever statement we say, we have to back it up with the reason. So if we have to say, figure out what is the missing angle in the triangle, we can say, well, if we add the three angles together, that has to equal to 180. So this statement that you've just written out, you need to justify why you're saying that. And the justification or the reason for that is angle sum. Okay. So angle sum of triangle. And then the second part, or the second property of any triangle, is that the exterior angle of a triangle is equal to the sum of the two interior opposite angles of the triangle. Okay, let me explain what they mean by that by drawing a little diagram. So let's say we have a triangle over here. Okay, there's my triangle. Now, an exterior angle is an angle outside of the triangle between one of the lines, one of the extended sides. So what I'm going to do is I'm going to extend any one of these sides. So let's say I extend that side. So the angle that is formed is this angle here. This is the exterior angle, okay? And it's formed between the extended side and another side of the triangle. So now what they're saying is that this exterior angle here equals to the sum of two opposite interior angles. Okay, so this angle here and this angle here. My pen is running out. Let's use blue. Okay, so now let's think about it, right? Why is this the case? Why do we have that this angle here has to equal those two angles? Okay, well, think about what we're dealing with, right? So what I'm going to do is I'm going to call this angle across like that, okay? So basically, if we're looking over here, then let's call this a circle, and these two will be the two open dots, okay? So I'm just denoting these angles like that. So if we look at these two here, these two have to equal to 180 degrees, right? Because it's angles on a straight line. So 0 plus x equals to, okay, it's bad names, 0 and x, but let's just go with it, equals to 180 degrees. And the reason for this, angles of triangle, or sum angles of triangle. Okay. Right. Okay, so that's great. Now let's look at these three, right? So also we have that the solid dot, this plus another solid dot, plus x must equal 280 degrees. Okay, because angles of a triangle sum up to 180 degrees. Actually, I got this wrong. This should be the second reason, because we're doing angles of a triangle here. So this should be angles of, sum of angles of triangle. Okay, and the top one, this is going to be angles on straight line. Okay, and we know that angles on a straight line add up to 180 degrees. Okay, right, so now if we look at these two statements, what we can notice is that there are some common things going on. So all of these angles both equal to 180 degrees. Okay, both of them on the left-hand side have an x. Okay, so that's the same, that's the same. Okay, since they both equal 180, whatever we have here must equal to here. These x's are the same, so we can say that therefore this angle here has to equal those two. Do you see? To make it 180 each. So this open circle equals to a closed circle plus another closed circle. Okay guys, I should have actually used letters and made it a little bit better. But the point here is that the exterior angle of a triangle equals to the opposite interior angles. Okay, now you might be thinking, okay, but hang on a second. What if we extend this line here instead of that line? Would anything change? And the answer is no, nothing would change. Why? Well, let's do that. Let's extend this line over here. So there it is, there's the blue line. Okay. Now, instead of having that interior angle, exterior angle, we have this exterior angle, which is over there, right? But remember, these two angles are exactly the same. Why? Because they are vertically opposite each other. You see, if two lines cross like that, the angle here and at the bottom is the same angle. So that is the same as that. And this is the exterior angle, and these two are still interior angles of this exterior angle. So really, it doesn't matter what exterior angle we take, whether we extend this line or that line, it's the same thing, and it's always equal to the opposite interior angles of the triangle. Now we can swap this thing around. We can take any exterior angle. If we say extend this line over here, right, and we have this exterior angle over there, okay, well that has to equal to this angle and that angle, okay, using exactly the same principle as we've gone through before now. Alright guys, so that is the explanation of this theory. So remember, you want to remember these explanations or statements, right, or rather reasons for the statements, okay, because when you're answering a question, you're going to get a mark for this side and a mark for that side. In matric, when you're writing this section, if you don't give me both, you don't get a mark. Okay, so you really have to explain why you are saying what you are saying. Okay. All right, cool guys. So those are the two properties of triangles. Okay. Right, let's continue. You can show these two important angle properties as follows. Okay, so what we've done is I've explained it on the board about the exterior angle of a triangle, and angles on a straight line add up to 180 degrees. Well, we already know that from having a straight line. Okay, so now let's move on to the next section, which is solve geometric problems with angles and triangles. Right, you can use what you know about the properties of lines, angles, and triangles to solve geometric problems. Geometry often relies heavily on algebra, and in this section you will use algebraic equations to solve geometric problems. Okay, so the main idea here with these problems is that we have to find some theory in the question that links the missing info with the info that we have. We put that into the equation, we justify why we're using that equation, and we solve the equation for the unknown, which is usually x or y or whatever it may be. Okay. Set up the equation by using the information you have been given about the angles or triangles, and then solve the equation algebraically. sketches will not necessarily be drawn to scale. Now remember, in construction, everything is according to scale and is done perfectly. In geometry, I don't have to draw things according to scale in my question paper. So I could draw an angle like that and call it 90 degrees, even though visually it doesn't look like 90, but you have to take my word for it. So that's part of the trick to, test you whether you understand whether it is 90 or not, or whatever the question might be asking. Okay, but don't stress too much about that. We'll go through examples and you'll see exactly how we solve these things. Okay, right, so let's look at the blue box on page 115. The exterior angle of a triangle is equal to the sum of the two interior opposite angles. Yes, we know that. The sum of the interior angles of a triangle is equal to 180 degrees because angles of a triangle sum up to 180. And the sum of angles in a straight line is also equal to 180 degrees. Okay, so those are the properties that we know so far. Right, let's look at the example. So we have in triangle ABC, AB equals to AC. Okay, now as soon as you have two sides that are equal in a triangle, you should be thinking that the two angles are also equal. And it says angle A equals 4x minus 10 and angle B equals x plus 5. Okay, so on the right hand side, they've drawn us a triangle. I'll redraw it on the board. Okay, so we have triangle ABC. AB equals to AC. So AB equals to AC. Right? Angle A is 4x minus 10. 4x minus 10. And angle B is x plus 5. Okay, so that's the only info they give us. And they say to us, state the size of C in terms of x and give reasons for your answer. And also 2, determine with reasons the value of x. Okay, so first thing we need to express angle C in terms of x. Okay, so that means that we're not solving for x yet. We just want to use the info in the triangle to find what is angle C in terms of what we already have. Let me write this a bit bigger. I don't think you guys can see that. So it is 4x minus 10. Okay. Right, so let's now think the two ways we can write angle C. Okay. Well, one way is to say, well, angle C equals to 360 degrees minus that angle minus that angle. Okay, so whatever we have should be that. Or we can say that, well, this side equals to that side. So this angle and that angle must be the same because of the isosceles triangle. All right, so here we're going to say this is x plus 5. Let's see what they did in the textbook. So they said x plus 5 is right, but if you guys went 360 minus the other two, I would have also accepted your answer because it's still correct because angles of a triangle still add up to 180 degrees. Sorry. All right, so now we're going to say that angle C equals to x plus 5. What is the reason for that? Well, the reason is that AB equals to AC. And we could say isos triangle. Okay, but AB equals to AC is also just fine. Right, so we solved for C. Now they want us to find the value of x. So we need to think of an equation that's going to take all these values into consideration and have it equal to something that we can now solve. Well, what can we use? We only have a triangle with interior angles, so we're going to use interior angles of a triangle sum up to 180 degrees. Okay, so let's do that. So let's add all of these together. So we have x plus 5 plus x plus 5 plus 4x minus 10. And that has to equal to 180 degrees. Why? Well, what is our reason? The reason is sum of angles of triangle ABC. Okay. Guys, you don't always have to say triangle ABC. When we're dealing with one triangle, there's no need to do that. But if you have, say, a drawing with multiple triangles, you've got to tell me which triangle we're talking about. Okay. Right, so let's simplify that. We have x plus 4x, that will give us 6x. 5 plus 5, that's 10, minus 10, well, that's 0. So 6x has to equal to 180 degrees. Now, guys, remember, when we state the reason here once for the initial statement, you don't need to tell me anything else for your calculations going down. Okay, so 6x equals to 180. Divide both sides by 6. So the 6's cancel. And we have that x equals to 180 over 6 is 30 degrees. Okay. Right, guys, so that's how we're going to solve these questions. It's always the same thing. Find the statement, the statement, then you've got to give me the reason for the statement, and then you're going to solve your statement and see what you get. Okay. Right, cool. Let's go to the next example. Okay, so the next example says, in this figure, q equals 3x minus 12. All right, so let me draw this figure. Okay, so that's the drawing that we have. Let's go through it. So in this figure, angle Q equals 3x minus 12. Okay, so here's angle Q. Okay, so the problem with what they've done here is that they've called it angle Q, but here we can clearly see there are two angle Qs. Okay, so a better notation wouldn't be angle Q, but to actually call PQR. Okay, PQR would equal to then this value over there. Okay, right, so we got that angle PRT. PRT is given to 4x plus 32, and PR equals to QR. PR equals to QR. There's our markings over there. Right, so what do they actually want from us? One, state the size of angle C in terms of x. Give reasons for your answer. Now I'm reading the wrong question. Number one, express angle P in terms of x and give a reason for your answer. Okay, so we need to find this angle in terms of x. Okay, well, let's think. What theory can link this angle, this one, and this one? Well, remember the exterior angle of a triangle, which is this, equals to the two opposite interior triangles, okay, or interior angles. So that's all that we need to do. We need to state that in a number sentence or in an equation, give a reason, and solve. Okay, so let's do that. So remember, this angle is called angle P. So what we're going to say is that 4x plus 32 degrees equals to this angle plus that angle. Okay, so it will be 3x minus 12 degrees plus angle P. Okay, right, remember we are after angle P in terms of x, so we are solving for P. We need to take both of these to the other side. Okay, so we got 4x. When this 3x comes over, it becomes negative. So 4x minus 3x will just leave me with an x. And then here we have minus 12. When it comes over, it becomes positive 12. 32 plus 12 is 44. Okay, so this will be plus 44 equals to angle P. Okay, so angle P is x plus 44 degrees. Okay. Right, so is that what they get there? Okay, that's not what they get, but it's not a problem because what they are doing here is that they're using opposite angles. Okay, so they're basically saying that this side opposite this angle is 3x minus 12, which means that this angle here opposite this side must be the same. So these two angles must be the same. Okay. So we could have called angle P 3x minus 12 because we have an isosceles triangle, or we could use the exterior angles of triangles. So here I've used the exterior angle of triangle. So, okay. Right, so we got that. Guys, both answers would be correct. I would mark either one right. Okay, number 2, copy and complete the statement. Copy and complete the statement by filling in the names of the missing angles. Also give reasons for your answer. So in the example, they say angle PRT equals something plus something. Okay, so all they're doing is they're rewriting this exterior angle that we've already done. Okay, so they say angle PRT equals this angle plus that angle. And that's what you need to fit there in the answer book. So it's angle P and angle PQR. Number 3, calculate the value of x by using your answers to question 2. All right, so now remember we have two ways to calculate this, right? We could say that, well, this equals to this plus this, or we can say that, well, we know that this angle here has to equal that angle there, okay, because they are isosceles angles. All right, isosceles triangles. So let's try that method and see what we can get, because they obviously used 3x minus 12 and 3x minus 12 over there. So they could say 3x minus 12 plus 3x minus 12 equals 4x plus 32. We're going to try another method where we're going to say, well, that angle has to equal to that angle because they are the same, and we're going to solve for x that way. Right, let's try that. Let's see what happens. I'm pretty sure we're going to get the same answer. So we'll say that, well, because this is an isosceles triangle, x plus 44 equals 3x minus 12. What is the reason? Isos triangle PQR. Okay. Now let's solve for x. There's 3x there. I'll take this x to the other side, and I'll take this 12 to the other side. So this x goes to the other side. It becomes negative. 3x minus x is 2x. This minus 12 goes to the other side, becomes positive. So it is 56. Okay, 56 equals 2x. Divide both sides by 2. That cancels, and we get x equals 2. 56 over 2 is 28 degrees. Okay, moment of truth. Do they get 28 degrees? Yes, they do. Okay, so x is 28 degrees, and the answer is exactly the same. So we were a little bit smarter than the textbook in terms of going straight to the exterior angle and solving the question, rather than using the isosceles property of the triangle. Guys, which brings me to my next point. When you are doing these geometry questions, remember there's many ways to solve the same problem. Okay, so one solution doesn't have to be the only solution. Okay, like we've done over here. So in the textbook, they've did it one way. I'm doing it another way. All right, guys, so what I want you to do is exercise 11.2, which is almost exactly the same what I've done here. It will give you some practice, and yeah. And we'll continue with identifying classified quadrilaterals in the next lesson. Cool, guys. Thank you very much. I hope you enjoyed it, and I'll see you next time.